one of today's most prominent and advanced physicists has expressed his opinion on the matter. Michio Kaku, recognized for his outstanding contributions to the field of physics, has recently confirmed that the James Webb Space Telescope has discovered 6 massive galaxies that scientists previously thought could not exist. These investigations have the potential to open up new dimensions in our scientific understanding of the universe. It is, therefore, exciting and worth keeping an eye on these developments. Michio Kaku is an outstanding figure in the scientific field, a physicist of American and Japanese origin. He is considered an expert in both classical experimental physics and quantum mechanics. Unlike some more conservative and skeptical scientists, Kaku does not belong to that group and has been receptive to the astonishing results of the James Webb Space Telescope mission. We are delighted that this distinguished scientist has decided to break his silence and publicly share what can no longer be denied. The enthusiasm and almost amused tone of the renowned physicist are evident in his comments on the discoveries made by the James Webb Space Telescope, expressing that this has been the highlight that has piqued his interest. Join us to discover the implications of Michio Kaku's discovery of these 6 massive galaxies. Michio Kaku has always been willing to consider new theories throughout his career. He recognizes that Einstein's equations of relativity and Newton's laws are insufficient to capture the full complexity of the universe. Kaku understands that the discoveries of the James Webb Space Telescope have the potential to enrich the scientific field. Although many of his colleagues have been unable to adopt this view, it is generating concern and insomnia among proponents and opponents of the Big Bang theory and quantum mechanics. However, this only provokes laughter from Michio Kaku. The James Webb Space Telescope has revealed the discovery of 6 massive galaxies dating back to the earliest times of the universe. Each of these galaxies contains more stars than our own Milky Way, despite having formed only 200 to 700 million years after the Big Bang. The team of astronomers who made this discovery has dubbed these exceptional galaxies universe breakers because, if confirmed, they would revolutionize our entire understanding of the universe. Something doesn't fit anymore. The Big Bang theory tells us that the cosmos was a chaotic environment after the initial event. The first solid objects took hundreds of thousands of years to form, and it took hundreds of millions of additional years for these objects to reach sufficient density to produce light. The formation of complex structures such as galaxies was assumed to occur much later. Some of the newly discovered galaxies exceed the Milky Way in size, and their immense luminosity indicates that they were probably forming hundreds of new stars each year, whereas our galaxy forms stars only sporadically. It remains uncertain exactly when the first galaxies formed. Researchers have not yet been able to determine this. The only thing that is clear is that initially, there may have been only single stars or groups of stars, which eventually joined together to form larger and larger structures until dwarf galaxies developed. These small galaxies encountered others and gradually grew. According to previous theories, highly organized and massive galaxies could not have existed at that time, which raises the question of whether the universe is much older than previously believed or whether complex galactic arrangements developed much earlier. This circumstance is difficult for conservative science to accept. Some physicists heavily refuse to acknowledge this discovery and question potential errors in age calculations. Michio Kaku is aware of this and commented that there are many examples of old and false theories that stubbornly persist due to the prestige of some scientists. Many of these theories were only discredited when a crucial experiment revealed their flaws. Therefore, fundamental work in any science, especially physics, rests with the experimentalists who keep the theorists honest. On Earth, we know very little about the true beginnings of the cosmos. The Big Bang theory, established in 1927, was based on observations of the universe's expansion. These data led to the conclusion that the cosmos originated from a single point and has been expanding ever since. At the time, it was difficult for people and scientists to conceive of a universe with a beginning and an end. The idea of a universe that had always existed and was infinite in time and space was beyond imagination. Even today, scientists face difficulties in fully understanding it. It is important to consider these probabilities once again. These new findings do not align with what researchers have based for decades on the Big Bang theory. However, science has shown time and time again that re-evaluation and openness to new ideas are integral parts of the scientific process, just as much as confirming certain theories through observations. When Einstein was a child, it was believed that stars and planets were fixed in the universe and that specific structures occupy defined spaces. However, we now know that everything in the cosmos is in motion. Planets orbit stars, stars move within their galaxies at hundreds of kilometers per second, and entire galaxies move rapidly through the universe, their ultimate fates unpredictable. Today, scientists are challenged to accept uncomfortable truths and understand that theories are only hypotheses, not absolute truths, until rigorously tested and confirmed through accurate observations. The idea of the Big Bang arose from realizing that galaxies are moving away from each other and that this distance is proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe was expanding. For a long time, elements such as cosmic background radiation and the redshift of light from distant galaxies seemed to support this theory. However, history reminds us that people once believed the Earth was flat and that the Sun revolved around it, supported by what they saw as valid evidence. Only through coincidence or technological advances did a clearer and more accurate picture emerge. Right now, we are witnessing a similar situation in the realm of modern cosmology. Scientists expected the new Webb space telescope to confirm assumptions related to the Big Bang. However, they instead came across 6 galaxies that seemed impossible. This discovery reminds us that science is constantly evolving and that scientists must remain open to new discoveries, rethinking existing theories based on available evidence. Researchers use redshift as a tool to determine certain quantities in the study of the cosmos. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source and the observer move relative to each other. To understand this, imagine standing still as a car approaches. As the car moves toward you, the sound of the engine gets louder. Once the car passes or moves away from you, the sound of the engine changes. This happens because the sound varies with the car's motion. The same principle applies to light. When a light source, such as a star, moves closer to us, the light shifts toward bluer hues. Conversely, when the light source moves away, the light shifts toward redder hues. This phenomenon is known as redshift. Physicists have converted redshift values into velocities and distances for measuring cosmic phenomena. However, it is important to note that small errors in these measurements could lead to significant effects. The techniques previously used for these measurements are currently under review, and it will be interesting to see what results scientists arrive at. Regarding recent observations of our cosmos, it is necessary to consider whether they are genuinely due to redshift errors or if some scientists are denying certain facts. This question requires rigorous analysis and a careful review of the data and methodologies used in research. Thank you very much for watching the video. As always, we remind you that you can post your doubts in the comments box. If you liked the video, do not forget to hit the like button, share it to reach more people, and subscribe to the channel so you don't miss more content like this. Thank you so much.